This video looks at converting from polar to component form. Now there are formulas, as I alluded to in the last video with the example, that you can memorize. If you don't memorize them though, you can just use your trig knowledge. So it's not required. So where these formulas come from, if I have my triangle, my right angle is here, so my hypotenuse, my opposite, and my adjacent. So when I'm dealing with my x component, that's my adjacent, I'll have my magnitude, so that's my hypotenuse, so that's AH. So my x coordinate is cos theta. When I'm looking at my y component, that's my opposite. Again, I'll have my magnitude. So for my y component, I'm looking at sine theta. Now you learnt that last year with your unit circle, that when we were talking about a coordinate on the unit circle, it was in form of cos theta, sine theta. So when you've got x, y, it's cos theta, sine theta. Alright, so we're just using that in regards to vectors. Now, in order to get these formulas, x's are cos theta, y's are sine theta, going from the triangle that I have here, we could write sine theta is opposite over hypotenuse, which is my opposite is my y, and my hypotenuse is my r. So that means y equals r sine theta. Similarly, cos theta is adjacent over hypotenuse. My adjacent is my x over my r. So x is equal to r cos theta. So you don't have to remember the formulas. You can draw a triangle and work it out. Now to go from component form to polar form, we've already looked at that. Again, you can use Pythag tan theta y over x, or you can remember the formulas r equals square root of x squared plus y squared, and tan theta equals y over x. Might even just want to do theta is inverse tan of y over x. And you can see that from the triangle. For Pythagoras, c squared is a squared plus b squared. A squared is my x squared. B squared is my y squared. So my magnitude is a square root of x squared plus y squared. So understand where these formulas are coming from, because if you're in an assessment and you stress, you're likely to forget them, and you can always work it out. Now let's look at some examples. Write each of the following vectors in Cartesian component form. So 330, my r equals 3 and my theta equals 30 degrees. So using the formulas, x equals r cos theta, which is 3 cos 30, which is approximately 2.60. Y equals r sine theta, which is 3 sine 30, which is 1.5. So my vector is going to be approximately equal to 2.60i plus 1.5j. Now again, if you forgot the formulas or you don't want to remember the formulas, completely understand. I didn't when I was at school. So draw the diagram. You've got your 30, you've got your 3, you've got your y, you've got your x. Label your diagram H, O, A, and you can work it out. So x is adjacent over hypotenuse. So cos theta is adjacent over hypotenuse. Cos 30 is x over 3. So x equals 3 cos 30. Similarly, if we're working out our y, that's opposite an hypotenuse. So it's sine theta is opposite over hypotenuse. Sine 30 is y over 3. So y is 3 sine of 30. Next one. Now the beauty of this, you can see this negative 60 degrees. That is telling us we're in our fourth quadrant. So in the back of your head, you need to remember that x is going to be positive, y is going to be negative. That's a good check. Now if you use your formulas, it will come out in the wash. So x equals r cos theta. So that's equal to 4 cos negative 60. Now because cos is positive in our fourth quadrant, when we go to our calculator, if we put in that negative 60, it'll come out as a positive, which is 2. Y equals r sine theta. So that's equal to 4 sine negative 60. So we're in our fourth quadrant. If we go to our calculator for this one, your calculator is going to spit out a negative answer because sine is negative in the fourth quadrant. So that's approximately negative 3.46. So my Cartesian form for u is going to be approximately 2i minus 3.46 j. Now, if you didn't use the formulas and you used your diagram, make sure you draw your diagram in the direction it's meant to be. Okay, so fourth quadrant, your triangle goes down. So this angle is 60. And there's my 4, there's my x, there's my y. So nice and straightforward, just like before. Cos theta is adjacent over hypotenuse. Now put in the positive angle. Cos 30 is x over 4. X equals 4 cos of 60, which is 2. And you know x is positive. When you go to your y and you go sine theta is equal to opposite over hypotenuse, sine 60 equals y over 4, y equals 4 sine of 60. If you plug that into your calculator, you're going to get a positive 3.46. You need to remember, because you're in your fourth quadrant, it's a negative. But that's why it's always good to come back and check or write what I've put at the top here to remind me that my answer needs x to be positive and y to be negative. You should be doing those checks anyway. Now I'm going to change this last one so we have it a little bit different. Let's make it 150 degrees. Okay, so to 150 degrees. That means we're in our second quadrant. So in our second quadrant, x would be negative and y would be positive. So when we use our formulas, we've got x equals r cos theta, which will be 2 cos 150. Now we're in our second quadrant, so cos is negative. And when you go to your calculator and plug it in, you'll notice you'll get a negative answer. It's negative 1.73. Y is r sine theta, which is 2 sine 150. We're in our second quadrant, so sine is positive. When you go to your calculator, you get a positive, and it's 1. So that means in Cartesian form, our u is approximately negative 1.73 I plus j. If you were to draw the triangle, this is your 150, so that means this angle here is 30, y, x, and our 2. So cos theta is adjacent over hypotenuse. Cos 30 equals x over 2. X equals 2 cos of 30. Now you'll get a positive. You have to remember that it's negative. So if you do it this way, you have to understand what quadrants you're in to be putting that into your formula. So sine theta is opposite over hypotenuse. Sine 30 is y over 2. So y equals 2 sine of 30, which is 1. Okay, so two different ways of doing these questions.